Ever-increasing pressure to meet business goals requires improved processes for every aerospace company. Consistent and successful program execution is mission critical. Program success in our example of adding a surveillance pod to an existing aircraft results from managing all of the complex systems in Teamcenter from Siemens PLM software as a system of systems. That's why every day companies reduce risks and increase the levels of success by using Siemens PLM software products. There are 5 areas required to enable consistent program success. Integrated Program Planning and Execution, or IPP&E, Systems Engineering-Driven Multidiscipline Authoring, End-to-End Virtual Verification for the product, manufacturing, and service, Global Supply Chain Management, and Production Realization. First, IPP&E is about improving decision support and tracking by linking all of the technical, cost, and schedule requirements of a program. Schedules are an integral part of PLM, and within the system, they are trace-linked to the associated enterprise data model. This enables teams to document in real time requirements achievement for certification. In addition, trace links enable rapid graphical-based statusing. Systems engineering first allocates requirements to functional models and logical models, then validates requirements using physical architecture and behavioral modeling. And PLM automatically generates trace link diagrams to show allocation of requirements.
Bringing NX and Teamcenter to the Spatial Research Centre allowed all our different groups to work more cohesively together. Our electronics engineers and manufacturing teams used to operate using completely separate softwares, and we found that there was clear separation between the mechanics group, the electronics group, and the manufacturing team.
In addition, mechatronics integrates the cross-discipline authoring activities necessary for complex product development, such as our surveillance pod. Within the system, the wire harness engineer can avoid wire harness interference problems. Early behavioral modeling includes the required test signal inputs, controller, drive motor, and the surveillance pod mechanical characteristics, which are supplied by NX. Together, the simulation predicts the overall pod performance.
With space design, what we do is we put a very, very sensitive bit of measuring equipment on top of the space rocket, and then the space rocket launches and it's subject to very, very high levels of vibration load. And we need to make sure that our hardware can withstand this vibration load, because hardware development is very, very expensive. We use the NX tools to really try and predict what stresses the hardware is going to be subject to during these launch level loads.
We find that the Nastran solver is a solver that is commonly used within the industry, so it allows us to work effectively with our partners. We also find the tools are particularly effective at providing good correlation to the actual design environments.
By using simulation results and with confidence in the information, the team can realize rapid optimization and achieve all requirements.
The new practice is to work in parallel. The team is combined. Engineers, production engineers, manufacturers, all the supply chain actually was brought together. It's an integrated product team. The Teamcenter allowed actually the environment outside of the design community to see all the product in parallel to the evolution of the product as part of the design. This process became a parallel process instead of an inline process, and that saved a lot of time. There's no room for improvisation.
Concurrent processes and enhanced collaboration reduced the need for face-to-face meetings, reduced travel costs, and allowed teams to work together in real time, regardless of location. With on-demand visualization of 2D or 3D data at their fingertips, all users have clear, concise, and visual information to make better decisions faster. Teamcenter delivers process-enabled collaboration that ensures accuracy and completeness and reduces costly errors.
By all groups now using Teamcenter and X, we're finding there's much more cohesive environment where we engage, we interact, we discuss the design issues, and we find that the iteration between getting that concept to the final product is becoming shorter.
Human simulation can optimize time per task. It can be used for training to improve learning curves. Human simulation also helps discover and prevent potential repetitive injuries on the shop floor before implementation. Profitable production rate can be obtained by modeling the plant assembly line and with a simulation that includes learning curves. As a result, the team can predict bottlenecks and ramp-up rates before costly shop floor implementation. With access to intelligently integrated information with a focus on results and with a commitment by the team, Siemens PLM software empowers companies today to put these and additional best practices into action and achieve consistent program execution excellence. IAI's G150 received certification from both CAII and the FAA 10 weeks earlier than planned, just 2.5 years from project launch.
First flight was in May, and the certification was in November that year. So that means 6 months from first flight. And it's a success in the market. Using the PLM saved us months, I would say 5 months, maybe 6 months. This is a lot of money saved to the company.